Hello, everyone. So I'm Mike, and I'm CTO at Coldstack, and today they stole my punchline, but I was going to show you that using React Native for your next mobile app might not be the craziest idea in the world. So to start with, how many mobile developers do we have here? Who's writing mobile apps here? Anyone? OK. And who's writing web apps with any kind of JS frameworks? All right, so you guys maybe want to write a mobile app after my talk. So let me start by explaining why. Why do we want to use something that's not native to write mobile apps? So compared to web development, mobile development is really kind of difficult, right? If only mobile development was similar to web in a couple of key areas, things would have been significantly better. And there was never a really good way to do this until Facebook came out and open source React and React Native 2 years ago, which is a framework that makes building mobile apps much more similar to the workflows that we know from web. And it's really exciting because not only it makes it faster, but also allows us to target multiple platforms at once. So what specifically am I talking about? Why is building mobile apps so much harder when compared to web development? So first and foremost, it's an issue of device fragmentation. Right now, the Android operating system runs on around 86% of devices worldwide. However, taking a look at the revenue streams, iOS is still generating around 38% of overall revenue from all the app stores. So given that fact, as a mobile developer, what platform do you target first? Do you build for iOS? Because you can potentially make a lot of money, but your app is not going to run on 8 out of 10 devices out there? Or do you build for Android and miss the opportunity to make money? So it turns out that this is a really tricky question. And if you are serious about mobile development, you have to target both these platforms at once. Problem is, this is super expensive and time-consuming, right? Not only you have to work with 2 separate teams of developers, or you as a developer work with a different team, but also there is a cost of management that you have to put into rolling out 2 versions of your app at the same time. And that is kind of bad because at that point you basically need a serious founding or venture capitals just to test out your MVP. Whereas rolling out your initial version of your app should be pretty simple, right? Another thing is development environment, because we use Xcode and Android Studio to write our mobile apps. And these IDEs are not really made with productivity in our mind. For example, when Xcode crashes unexpectedly, it has to reindex all of your project files next time you run your app, which is going to take a lot of time and can take you out of your flow and decrease your productivity. Another major difference when compared to web is the process of compiling, right? Every time you make a change, you have to compile your app over and over again, even if all you want to do is to just shift text up a bit. That kind of makes it slower and decreases the amount of hacking that you do with your app. So as a result, engineers end up working a lot slower, and the code bases and the process is slower even on larger code bases. So another issue is the distribution platforms, because on the web we could develop against open standards. And companies like Facebook or yours, even mine, have their own solutions and infrastructure for rolling out applications. We have our own infrastructure for testing, for deployment, and a variety of other things. With mobile development, you lose that control in favor of proprietary platforms. For instance, we no longer control the release cycle. Normally, on web, you would just deploy your web application to some sort of continuous integration systems and wait for the release to happen. On mobile, you have to compile your app, set it to the App Store, wait for the release, and then wait for your users to actually download the update. And in case of a bug, you have to wait for a long time to release those fixes, and then wait for users to download the update that fixes the problem. On web, it's pretty much easy because you can hotfix all the things. You can set instant updates, so we definitely want this to be like on web, where you can just instantly fix whatever happens during the release process. So that brings us to the question, why don't we just drop native? right? I told you so many bad things, let's say, about mobile development, so why don't we drop it and just write web? So even though developing mobile is harder, let's say, when compared to web, we still want to do it. There are reasons for that. And one thing is platform experience, right? Platform-specific user interface like maps, date pickers, switches, all that matters. It is possible to re-implement those with HTML, CSS, and some sort of other technologies. And there are already solutions that do this. But if you've been using some sort of platforms for a long time, you'll notice the difference between, let's say, fake component and the real one. Another problem is that those components will not be updating along the system. So if you have an app that has a custom, let's say, iOS header, and iOS changes the entire UI from the old one that used to be to iOS 7 that had the new one, you will have to roll out a new version of your header as well. Another major issue is gestures. And we don't have anything as sophisticated as the native mobile gesture recognizes on the web. And we don't yet have proper tooling or discipline to roll this out on web. Problem is that web wasn't really made for those advanced gestures like pinch to zoom or rotation. So it's kind of hard to make it smooth and snappy when you are writing a web app. Another issue is threading. Because on the web, we also don't have a sophisticated threading model. Of course, we can use some sort of web workers to overload heavy computations, but still, it's not kind of suitable for advanced computations that you can do on the mobile, like image processing, decoding, and make that work nicely with the UI thread. So that's how things on mobile looked quite recently. And the reason I'm standing here is that I'm trying to show you some possible solutions, how we can combine platform-specific user experience with agility we know from web to achieve something that's going to make us more productive. So, of course, one of the possibilities that we know for quite a while, and I've already talked about it, is the web view. It's an interesting alternative because it allows you to take your entire web app and just put it to the App Store using some sort of wrapper like Cordova. And it's kind of nice. However, one remarkable issue that I told you about is the platform experience, because you won't have the snappy interface that others have. So it might be suitable for things like lists or displaying static data or rolling out something quickly, but if you are serious about mobile development, you definitely want something that can provide you with a first-grade experience. So if only we could make JavaScript somehow to call into native APIs, we should have power to all the native environment, but also be able to iterate quickly and get the advantage of platform-specific components. And because it's just JavaScript, with a little abstraction, we could possibly make it cross-platform. It sounds like everything we want, right? And it's not a surprise if there are people that are following Angular. There is a framework called NativeScript that does exactly that thing. So it's a very popular solution, let's say, and it's been already explored for quite a while. Problem with having direct access to native APIs is that it can get very tricky. Because there are several issues with having such an access, especially when because there is some sort of overhead between calling overhead every time you call from JavaScript virtual machine to native environment, right? And even if you are trying to cross the threading boundaries and call between threads or do some async processing, that overhead will be even more noticeable. So if we don't do this correctly, there is a possibility that our application will behave even slower than a web app, right? Because we can slow it down pretty much. At the same time, if we do it right, if there is a way to do it right, we can optimize our applications by performing some sort of common techniques to make it fast. So to make it possible, we have to make a fundamental change to the way we think about writing code and switch to async model as far as the UI goes and layout goes. And luckily, there is a JavaScript framework called React that brought some radical ideas a few years ago about how to structure our user interfaces. And there are many great things about React, but today what really stands out, and I'm going to talk about, is the fact that it's a declarative framework. So How many of you have heard or know what's the difference between imperative and declarative programming? All right. So good, because I have an explanation for the rest. So imagine building this simple UI component. It looks kind of mind my design skills, but it's meant to be a button. Usually when you open some websites like FilmWeb or Netflix, you got a star component to star rate the current item. So this is the single part of that component that can be clicked in order to indicate that you favorite a currently displayed item. So it can have two states. And normally with imperative code, what you would do is you would check if the current listing that you are viewing is favorited, and if it is, and the icon is not yet selected, you would select it. Otherwise, if it's selected, you would unselect it to maintain the state. So with imperative programming, the focus is on how your UI transitions between states, right? As you can see, we are explaining how our UI should change along the state. And the problem with that is that it is very fragile and can grow quadratically as you add up other states. And with React, the declarative way, inside our render method where we are supposed to return our component, we check whether the current item is favorited, and we return the selected icon. Otherwise, we return not selected icon. So the difference here is that we focus on the UI for a given state. As you can see, we don't describe how the UI should transition. What we do instead is we show what our UI would look like for this particular state. So to wrap up this part, functional UI is the core principle of React. Rendering UI is a pure function of your view that takes some sort of state and returns the representation of your application. That also means that your entire UI can be composed out of separate components, just like you can compose functions with functional programming. And since there is no imperative code or stateful code inside, and those functions are pure, you can take an arbitrary component from even a different project without having any assumptions about how it works, and it's still gonna behave the way it's been designed. So that brings us to the very important question: how does React transitions between those views? Because, right, we are not describing transitions, we are describing state, but the state has to change somehow. So one idea would be to throw away whatever we have currently on screen and just replace it with the new UI that we just got from the function call. But that would be quite inefficient, right? So what stands out about React is that it can calculate the difference between your views. And that process is called reconciliation. It will go and compare the previous view and the new view representation and find the smallest set of changes that have to be applied. And the beauty of React in that particular case is that that process is abstract. With web, React goes and talks to the DOM, and if you have a component, it will, for example, talk to the div, and it will replace its border or apply some style. But it's very easy to replace DOM with something else, with any imperative layout system. For example, we could replace DOM with UIKit for iOS, and that's exactly how React Native was born. It's essentially React, with an exception that instead of rendering to DOM, your application is being rendered as a native iOS or Android application. With other platforms coming soon, there is already Windows Phone being launched, tvOS, and a couple of others, so it's pretty kind of evolving area. And thanks to using JavaScript here, things like hot module replacement, maybe I'll quickly explain. Thanks to using JavaScript, we can use the workflow that we know from web. So for example, we can use hot module replacement, which works in a way that, imagine you are working on an application, you have an application open in a browser, and you are editing a file. You change a line of code, so normally what you do, you go and you reload your browser, right? Because you want to see your application once again. With hot module replacement, we are able to replace the code that you have changed without reloading or losing the state. So that gives you the ability to, for example, play around with styling of your mobile app without recompiling it over and over again. Also, a very interesting concept is that you can roll out over-the-air updates. So for example, what you can do is imagine that you have an app that has a bug, and actually a good case is Amazon has React Native application to browse their store, and what they did recently is someone made a very common mistake. They shipped dev build to production. So users that downloaded Amazon application, they were able to see DevTools and play around with some debug information that was not meant to be public. So what Amazon did, they just rolled out over-the-air update. So it replaced the broken code so quickly that we didn't even have time to capture what did happen. And this is, by the way, let's say, approved by, for example, App Store for now. If we've been recently debating whether it's, let's say, allowed to replace code over the air without going through the App Store review. JavaScript code that is being hosted by the iOS virtual machine is the only way to replace the code. So as of now, using React Native is the only legal solution to replace the code once you release your application to the App Store. And here it is in action. If you haven't done any React or JavaScript development in the past, this may look a bit mythical, but it's a React component which is defined as a class. It renders a star that we just seen on the previous slide. It defines a state that holds an information whether our star is toggled on or off. And then we have a render method where we check for state, we get the icon to return, and we return it. Additionally, we wrap the icon with a touchable opacity component, which is a component that abstracts away the gestures logic. So it defines a method onPress that will get called as soon as I press that icon. And when I press that icon, I want to set state so that I can mark the current listing as a favorite. And what's important here is that set state doesn't necessarily change the way your application looks like. What it does is, as soon as you call set state, React is notified that change should be performed, and it should go over your application, compare it at pane once again to screen. So another cool feature about React is that it's cross-platform by default. On the previous slide, we can see that there is a touchable opacity image component. That code can run on iOS and Android without any modifications. So cool feature is that it's been designed with cross-platform in mind. And we will talk about the API surface later, but that image and touchable components have their different implementations on Android and iOS. So for example, image on iOS is some sort of UI image, whereas on Android is a different implementation, I guess, from even third-party library. And at the same time, React Native makes it very easy to write platform-specific code. Right? Its slogan is to learn once the paradigm, which is React, and write your apps everywhere, which is, for example, iOS, Android, or web. And we all know that 100% code reusability is not really a thing, right? People keep saying that you can write your code once and run it anywhere, but that just doesn't work from business perspective. I can't think of any mobile application that would work as is on all, and it's not a game. Because essentially, for example, on Android and iOS, the header is different. It has a different back button, so it's essentially a different component. And that's why React Native makes it super easy to provide platform-specific user interface where it makes sense. And there are various techniques to do it. One of them that I can highlight is the platform extensions. When you write require and put the name of the file, this is the way to load an external file and its implementation into your code. And as you can see, if you have index.ios.js and index.android.js, depending on the platform, a different file is resolved. So on Android, it will be that one, whereas on iOS, it will be this one. So that allows you to swap behind the scenes. You can provide different implementations for different components and expose nice interface back to your users so they don't have to think about it. So that's all about platforms and how to make cross-platform code. But what's really important to me when I first saw React, after being an iOS developer for quite a while, was the layout part. Because layout is super hard, and it's not just about mobile, but also about web. It describes the size and positions of your views on screen and the relations between them. And traditionally, layout is handled by different systems on each of the platforms, right? On iOS, you have auto layout and constraints. On Android, you have composable containers, whereas on the web, you have CSS-based frameworks, which just makes it hard to iterate on product because you have to know them all to be productive. So what React does is it provides a common interface, a cross-platform layout library that is based on Flexbox, on CSS Flexbox, and allows you to lay out your components in a row or column-based way. So you can, for example, define a flex direction, which will tell React to whether distribute your items along vertical or horizontal axis. There is also justify content that you can use to control whether items are left, center, or right aligned. As you can see, there are some ways to do more advanced styling, like space between and around. And a cool feature is also flex wrap that allows you to indicate that, for example, if the subviews are automatically overflowing the parent container, you can wrap them onto the next line. So let's take a look at the example of what I'm talking about. This is a very, very simple React component. It's an app component that has 3 children. They are empty just for the sake of styling. This is pretty much how you will start any React Native application. And this is how it looks like on a real device. So 3 containers, one parent, 3 children. Children are blue. So we told the parent container to lay out children in that way by specifying 3 properties, 3 flex properties. Flex 1 tells it to grow and take maximum available space. Since this is a root component, it will take all of the screen. Flex direction row tells it to lay out children horizontally, whereas the justify content space between tells it to maintain equal space between all the containers. So as you can see, it's just a matter of 3 properties to make some sort of, let's say, complex layout, which will adjust to any screen size or any orientation that you can think of. So that makes our user interface predictable, as we can write complex layouts in a cross-platform manner, and you don't have to think about platform differences. Because, for example, on Android, there is no overflow. On iOS, there can be overflow. So there are some sort of platform nuances that you have to think about, and that's what React Native helps you to do, to write something using common abstraction without thinking about details. Another thing I wanted to talk about today, which is very important from an application perspective. Clients often ask me on a regular basis whether they should go with React Native. I get questions like whether React Native is stable, whether it's mature, whether it has all the features, because on GitHub there are like 5,000 issues, no one knows what to do. And so my answer in all these cases is that with React Native there is no commitment at all. Doesn't matter whether you are building brownfield or greenfield application. So how many of you have heard of those terms already in the past? All right. So brownfield development is a term that describes need of new software to be developed in the immediate presence of already made existing legacy code. That's by definition, by reality. What that means is you have an existing Android application or iOS application, and you want to use React Native to write some sort of functionality. And I'll give you a great example of such application. It's Airbnb. They used to have a fully native application for quite a while, and recently they've launched their new version along with some additional features like Airbnb experiences. And that application, its main screen, it's native. But if you will go to details of, for example, room, this is React Native. So what Airbnb did is they kept native functionality for, let's say, very critical from the user perspective screens, and they kept testing out React Native on less popular screens like, I don't know, Help or something like that. And React Native provides a lot of nice, let's say, integration points for such applications. One of them is, which is probably already similar to native developers, is that you can create a root view, which is a React view. This is a subclass of UI view, so this is just like any standard UI kit view that you would have made on iOS. We tell it to create a new React view, and we tell it what's the bundle URL. Bundle URL is what you have, for example, if you use Webpack to bundle your application, you create a single JavaScript file. So that's the bundle, and you give it the URL. Module name is the name of your application, because, for example, imagine that you are building a native app, you have many screens. So you want to make multiple React Native screens, and this is the place where you can decide which one to load. As far as greenfield goes, greenfield is a term that describes development with no constraints imposed by prior art. So what that means is you just have a product idea, or you are rewriting app from scratch, and you can start with React Native. So this is very easy, right? But when you are starting right now, you don't know if, let's say, a year after, you will have all the APIs there. What if your client comes to you and say, I want the streaming, I want live video functionality, I want fingerprint reader. And you go open GitHub, no API. You look for already made library, no API. So that's a problem. Fortunately, React provides a great solution for that, which is a plugin architecture. The entire React Native is built on top of plugin architecture that allows you to call into native code and native code to notify back JavaScript code. So let's take a look at an example of such extension on iOS that is written in Objective-C. Here we define a calendar manager, and you can see that there is a heavy use of macros. For example, RCT export module is a macro that is during the compilation step, it is expanded in a way that it notifies React that this particular file is going to be a module. And then we use RCT export method to indicate that this method can be called from JavaScript thread. And this is how it looks from JavaScript side. There is the calendar manager object, which is dynamically created by React Native during the runtime, and it has add event method that's been created dynamically as well. So calling those methods will enqueue a call to be made on a bridge, which solves the problem of scripting and threading, because this is done by React Native for you. And those methods can be also async, can return a promise or a callback if you need async responses. Another special case of a bridge module is a view manager. Now, view manager is only different from a bridge module in a way that it has a view method. And that view method is supposed to return an instance of a native view to be created. In this case, I'm going to return mkey map view to create a map view. And then we can use a require native component from JavaScript to obtain a dynamic instance of your component to render. And then it's pretty simple, because all you have to do is to just return it from your React component. So what React Native will do in that case, as soon as it starts rendering your component, it will go to your view manager, and that method will be executed. So if you will put a breakpoint here, you will notice that it stops as soon as you return this component and it starts rendering. So wrapping up, I'm so excited about React Native. Unfortunately, it's not that popular here as it is in other countries. It looks like Angular here is more, let's say, appealing. Anyway, it attempts to improve mobile development in a few key areas by making it faster and more pleasant. It is a safe choice if you're looking into long-term maintainability. It is open source and doesn't have any lock-ins. So I encourage you to try it, and I'm pretty sure you will fall in love with it, just like I did 2 years ago. Thank you.